When Anthropic accidentally shipped the newest version of their official Claude Code NPM package, they included 500,000 lines of source code hiding in plain sight. Sitting openly in an R2 cloud storage bucket was a 60-megabyte source map file. Anyone who downloaded it gained immediate access to the raw internal TypeScript powering the tool. Social media immediately fixated on the superficial details, internal model aliases like Capiara, or an unreleased Tamagotchi-style ASCII pet hidden in the code. We are going to ignore all of that. The real value of this leak lies in addressing the primary limitation of agent design. Standard open-source AI agent frameworks rely on basic while loops and vector databases. In complex production environments, those baseline tools often loop infinitely or lose context. The source code reveals that Anthropic has discarded these standard baselines. They have moved toward an architecture built on language model native memory and strictly decoupled orchestration. This master architectural block diagram illustrates the three distinct technical pillars we will deconstruct from the codebase: Autodreaming, semantic retrieval, and coordinator mode. By examining how these specific systems operate under the hood, we get a detailed blueprint for how to graduate AI agents from experimental scripts into enterprise-grade software. This timeline illustrates the central problem of agent-tick interaction: context bloat. As a user operates Claude Code across multiple sessions, the system writes observations and preferences into a directory of Markdown files. Simply appending every new interaction into a single running file eventually degrades the system. This creates massive context windows, introduces stale information, and creates direct contradictions that corrupt agents' active reasoning state. Anthropic's solution, found deep in the leak, is a feature called Autodreaming, sometimes referred to internally as Chyros mode. It is a persistent two-phase memory architecture. The structure directly mirrors human neuroscience. It decouples the fast, raw episodic capture that happens during an active session from the slow semantic consolidation that happens offline. By pushing memory consolidation entirely into an asynchronous background process, the main agent maintains a pristine, lightweight active state, regardless of how long the user session lasts. This visual maps out the exact logical gates required to trigger that background consolidation. First, 24 hours must have passed since the last run. Second, at least 5 new sessions must have accumulated. And third, the system must acquire a lock so no other processes conflict. Once all 3 gates pass, the system spawns an isolated, read-only sandbox agent dedicated entirely to database maintenance. The operation runs in 4 strict phases. In Phase 1, Orient, the sandbox agent reads the existing index to map the current structural landscape. In Phase 2, Gather, the agent is restricted to scanning only the new, raw daily logs to find novel, relevant signals. Phase 3 is Consolidate. The agent computationally merges the new data into the existing topics. It is explicitly instructed to convert relative dates into absolute ones and delete facts that are now contradicted by newer behavior. Finally, Phase 4 is Prune. The system forces the final compiled index file to remain strictly under a 200-line hard limit. This 4-phase architecture reveals that Anthropic uses language models as literal background cron jobs executing automated database maintenance, rather than just chat interfaces. This split screen compares Anthropic's approach with the standard industry assumption. Most engineers assume that stateful agent memory requires taking text, chunking it, converting it to embeddings, and storing it in a vector database. But calculating cosine similarity is a geometric operation. It fails when an agent is attempting complex, abstract semantic reasoning that happens to lack exact matching keywords. The leaked code shows Anthropic bypasses vector databases completely. They use a secondary, lightweight language model, specifically Claude Sonnet, as the retrieval routing engine itself. During the extraction step, the system strips all Markdown memory files down, grabbing only the front matter headers, the name, the description, and the type. It packages this front matter into a lightweight JSON manifest and fires a parallel side query to Sonnet, instructing the model to select up to 5 relevant file names based on the active conversation. A frontier model natively understanding the semantic intent of a query will consistently fetch more accurate contextual memory than a mathematical calculation of distance. Anthropic refines this semantic retrieval further through a concept in the prompt called anti-noise gating. the system dynamically tracks exactly which tools the user has recently utilized within the active conversation state. For example, the code dictates that if a user is actively succeeding with a bash tool, the retrieval prompt explicitly commands the engine to skip pulling reference documentation for bash. A standard vector DB would fail here. Because the word bash is active in the chat, the database would blindly return highly ranked but completely redundant documentation. LLM native retrieval acts as a context-aware decision engine. It actively curates the main agent's context window to protect it from irrelevant bloat. The codebase also contains a hidden feature flag for coordinator mode. When enabled, the agent's execution loop completely changes, transforming it from a solo operator into a manager orchestrating a multi-agent topology. The system enforces a core constraint. The main coordinator agent is strictly forbidden from directly editing the user's codebase. This diagram shows the resulting workflow. In Phase 1, research, the coordinator dispatches parallel worker agents to investigate the code. These workers operate autonomously, sharing their findings in a permissionless central Scratchpad directory. Phase 2 is synthesis. This is the architectural bottleneck, where all research from the workers flows back up to the coordinator to be converted into instruction. The prompt engineering here is aggressive. The coordinator is explicitly banned from using vague phrases like "based on your findings." Instead, it must write absolute implementation specs containing exact file paths and specific line numbers. Phase 3 is implementation. Execution is forced into a strictly serial, per-file process, mathematically eliminating the risk of two workers creating merge conflicts in the same document. Phase 4 is verification. The system routes the new code to a completely fresh worker. This guarantees the tester carries none of the original coder's implementation biases. The verification standard is incredibly high. The prompt strictly requires the worker to run tests and prove the code actually executes, warning that simply confirming the text exists undermines the entire system. Reliability in these multi-agent systems emerges from strict isolated boundaries and mandatory peer review rather than giving agents operational freedom. The leak also revealed an internal feature called Undercover Mode, designed to strip AI attribution from public pull requests and commits made by Anthropic employees. While designed for internal security, it poses an immediate question for the open source community. What happens to code provenance and public trust when AI companies build dedicated tooling to conceal AI authorship? This unified architectural diagram shows exactly how Anthropic answers the engineering problems of scale. The next generation of AI tooling clearly discards rigid software paradigms, like relying on external vector databases for memory. It also moves past the early industry approach of letting single, autonomous agents run in unbounded loops. Frontier labs are actively utilizing language models as core foundational infrastructure. They deploy them as background cron jobs, dynamic database routers, and strict workflow orchestrators. Claude Code serves as a production-tested blueprint for an agentic operating system.